Today we get to start a geometry unit and look at Unit 7, Lesson 1, Relationships of Angles. So we did this warm-up in class today. Which angle is bigger, angle A or angle B? Okay, and at first some of you thought angle B might be bigger just because it looks like the sides are longer, but when we're looking at angles, we're just looking at the amount of turn that it happens, and angle A and angle B actually happen to have exactly the same amount of space in between the sides. So angle A and angle B are the same size angle. All right. If I ask you, what is the measure of angle A? What would you say? First of all, you might ask yourself, which angle is angle A? The last time it was kind of clear, but here it's not so easy to tell what angle A is. The reason why is because angle A is, there's a vertex right there, but does it refer to this angle? Does it refer to this angle? Does it refer to the entire angle? It's hard to tell what's going on here. For this reason, mathematicians often use 3 points to refer to an angle to be sure others will understand which angle we're talking about. And the vertex has to be the middle letter. So if I wanted to use this particular angle here that I'm drawing in red, I could call it angle DAC, or I could call it angle CAD, but I can't call it angle CDA or DCA or anything where A is not the middle letter. With that knowledge, which angle is bigger, angle DAC or angle CAB? Okay. I hope you answered angle DAC because that's 60 degrees. CAB is only 50 degrees. What if I ask you this? Which angle is bigger, angle CAB or angle BAC? This time I hope you answer, they're the same size. These are the exact same angle. They're just ordered differently in the letters, but A is still in the middle. Its angle is 50 degrees. Okay. A new vocab in 7th grade is called adjacent angles. Adjacent angles have to be next to each other. They have to share a segment. And this time, in this example, segment AC is shared, and they have the same vertex, angle A. So DAC and CAB, they're called adjacent angles. They're next to each other. Note, review from 6th grade a little bit. Angle DAC and angle CAB, those are both acute because they are less than 90 degrees. If I look at angle DAB, it's 110 degrees. Notice you can add 60 plus 50 to get that entire angle, and we'd call that an obtuse angle because it's between 90 and 180. Okay, let's examine some special angles. We want you to be really, really comfortable with these 3 types of angles. So the first one is a right angle. Right angle is just a 90-degree angle. If you have 2 lines that intersect and they form equal angles, each of those will be a right angle. It's like a corner. You can think of it as a quarter turn. A straight angle is 180 degrees. The 2 sides are going to form a straight line there. You can think of it as half of a turn. If you do a 180, you face the opposite direction when you're done. And a 360 degrees, that's once completely around a point. So you may often see these athletes, they go once around, that bike goes once around. You say they're doing a 360. Okay, over and over again, you're going to see this. Now, this girl does a whole bunch of 360s. Okay. So what are the 3 main types of angles in this lesson? We had a little bit of 6th grade review and then these special angles. The 3 main ones that we're doing today are a right angle, which is 90 degrees, a straight angle, 180 degrees, and once around a point, 360 degrees. Okay, what does it look like when angles are adjacent, and what can you say about angle measures? So you can always say 2 angles are placed when they have a vertex and one side in common, those are adjacent, and you can add the measures of those angles, adjacent angles, to make the full angle. So like if you had a 60-degree angle and a 120-degree angle touching, they would add up to 180 degrees. Okay, so our goals today, being able to find unknown angle measures by reasoning about adjacent angles, and also recognizing automatically if an angle is 90 degrees, 180 degrees, or 360 degrees.